Welcome to the deep dive. Today we're going deep into neuroplasticity.
Oh, very
Yeah,
good.
you shared some excerpts from Train Your Mind, Change Your Brain,
Mm-hmm.
and I am so ready to just get my mind blown about this whole concept.
Yeah.
That our brains can change throughout our lives.
Yeah.
That it's not this fixed thing that we're stuck with.
It really is a huge shift in our understanding of the brain.
Yeah.
For years, scientists thought that the adult brain was essentially hardwired.
Right. It was just too complex,
Yeah.
too intricate
Too many things could go wrong.
to mess with.
Right. You change one thing and who knows what the consequences could be.
Yeah, and there are billions of neurons and trillions of connections. It just seemed,
Yeah.
like you said, too delicate to even try to.
Yeah. That fear was understandable.
Yeah.
But what's fascinating is that as research progressed,
Yeah.
we started to see evidence that the brain wasn't nearly as fixed
Right.
as we once thought.
And that's where neuroplasticity comes in, right?
Exactly.
This idea that our brains can actually rewire themselves.
Yeah, one of the pioneers in this field is Michael Merzenich.
Okay.
He did these amazing experiments with owl monkeys.
Really?
That provided some of the earliest evidence of adult brain plasticity.
Okay.
He trained these monkeys to perform a very specific task using their fingers on a spinning disc.
Like monkey boot camp?
Yeah.
What happened?
Well, after the training, they found that the area of the monkey's brains responsible for processing that sensory input from their fingers had actually grown.
Wow.
The brain had reorganized itself in response to this new skill.
Wow.
It was a huge discovery because it showed that experience, not just genetics or age, could actually reshape the adult brain.
So if monkeys can physically change their brains by learning a new skill, think about what we can do. Could learning a new language or playing an instrument or even just
Yeah.
challenging mental activities
Yeah.
actually change the structure of our brains?
It's certainly a possibility. And it opens up some really exciting avenues for learning and personal growth.
Absolutely. Now, there's another group of monkeys that played a role
Mm-hmm.
in the history of neuroplasticity, but in kind of a controversial way.
Right.
And that's the silver spring monkeys.
Yeah, this case involved a researcher named Edward Taub who was studying what happens when sensory nerves are severed,
Oh, wow.
a process called deferentation.
Okay.
And he was looking at how animals adapt to the loss of sensation in a limb.
And unfortunately, there were some serious ethical concerns about how these monkeys were treated.
Right.
And Ingrid Newkirk and Alex Pacheco, who would later go on to found PETA,
Right.
brought those concerns to light. And it really sparked a major animal rights debate.
Yeah, it's a reminder that even in the pursuit of scientific knowledge,
Right.
ethical considerations must always be paramount.
Absolutely.
But despite the controversy, Taub's research led to an important discovery
Okay.
that monkeys could actually regain some function in a limb that had lost sensation if they were given intensive training.
So even though they couldn't feel the limb, their brains found a way to control it again.
Exactly. It was another piece of evidence that suggested that the brain can adapt even after significant damage
Uh-huh.
to find new ways to achieve its goals.
That's amazing. So we've seen how experiences can change the brains of monkeys,
Yeah.
but what about rewiring the brain at an even deeper level?
Uh-huh.
I'm thinking about the work of Ragunka Sur, who actually managed to make the auditory cortex of ferrets see.
Sur's work is truly mind-blowing.
Yeah.
He rerouted the optic nerve of ferrets to their auditory cortex,
Okay.
effectively bypassing the visual cortex.
So he was sending visual information to the part of the brain that normally processes sound?
Precisely.
Wow.
And what's incredible is that these ferrets actually learned to navigate visually,
Really?
even though the information was going to the quote-unquote wrong part of their brain.
So the auditory cortex, which is designed for hearing, could actually process visual information and help these ferrets see.
It seems that way.
That completely changes our understanding of how specialized different parts of the brain are.
It really does.
Yeah.
It suggests that the brain is incredibly adaptable
Yeah.
and that different areas can be recruited for new tasks depending on the input they receive.
It makes you wonder about, what if you were born blind or deaf? Would those parts of your brain that aren't being used for that be used for other things?
That's a great question.
Yeah.
And I don't know if we have a complete answer to that, but it certainly seems like the brain is capable of that kind of
Right.
adaptation.
And he didn't stop there, right? He did a similar experiment with mice rewiring their brains to send visual information to the auditory pathway.
You're right. And in this study, these rewired mice actually learned a fear response to visual cues
Okay.
much faster than normal mice.
Wow.
It's as if the auditory pathway, now receiving visual input,
Yeah.
could take advantage of its inherent learning mechanisms to process this new type of information.
That's incredible. So we're not just talking about the brain changing in response to experience. We're talking about different parts of the brain adapting to completely new types of information.
Right.
Like, it really highlights the flexibility of the brain.
Absolutely. It opens up a whole world of possibilities for understanding how the brain works
Yeah.
and how we might be able to harness its plasticity for things like treating sensory processing disorders or even developing new assistive technologies.
These studies with monkeys and ferrets and mice have shown us some pretty amazing things about the brain's ability to change.
Yeah.
But what about the creation of entirely new brain cells? That's got to be like the ultimate example of neuroplasticity.
You're talking about neurogenesis.
Yes.
The birth of new neurons in the adult brain.
That's incredible.
And this discovery really challenged the dogma of a fixed brain.
Yeah, tell me more about that. Who led that research?
Fred Gage was fascinated by this idea of neurogenesis.
Okay.
But when he first started researching it, many scientists were skeptical. The idea of the adult brain growing new neurons seemed too radical at the time.
Right.
So how do you prove them wrong?
Yeah.
Well, he had a brilliant idea.
Okay.
He partnered with another researcher, Thomas Bjork Eriksson,
Uh-huh.
and they took advantage of a unique opportunity.
Okay.
They knew that cancer patients were being injected with BRDU,
Uh-huh.
a substance that marks newly dividing cells to help track tumor growth.
Okay.
So they thought, well, why can't we use this to track new neurons as well?
Oh, that's smart.
So they obtained brain tissue from terminal cancer patients who had received BRDU injections.
Okay.
And when they analyzed the tissue, they found evidence of brand new neurons in the hippocampus,
Wow.
a brain area critical for learning and memory.
So they found new brain cells growing in adult humans.
It was a landmark finding.
Yeah.
It showed that even in adulthood, our brains are capable of generating new neurons,
Wow.
which has huge implications for understanding brain health aging and the potential for treating neurodegenerative diseases.
That's a game changer. So even in our later years, our brains are still capable of renewing themselves.
It really is.
That's hopeful.
It speaks to the incredible capacity of the brain for growth and regeneration throughout the lifespan.
This is blowing my mind. If our brains are constantly changing, adapting, and even creating new cells.
Yeah.
Imagine the possibilities for healing and learning and growth.
And this is really just the tip of the iceberg.
Yeah.
There's so much more to explore, including how therapies are harnessing neuroplasticity to treat conditions like stroke and depression.
That's what I want to dive into next.
Okay.
That's what I'm excited to talk about. It's amazing to think that we can actually rewire our brains. I'm eager to learn how this understanding of neuroplasticity is being used to develop new therapies.
Yeah, it's an exciting area of research. One of the most notable examples is Edward Taub's constraint-induced movement therapy, or CIMT,
Okay.
which has shown incredible promise in helping stroke patients recover function.
I've heard of this therapy. It involves restraining the unaffected limb and forcing the patient to use the limb that was affected by the stroke.
That's right. Might seem counterintuitive.
Yeah.
But the idea is to push the brain to find new pathways for controlling the weaker limb.
Okay.
By limiting the use of the stronger arm, the brain is forced to adapt and rewire itself.
So it's like overcoming that learned non-use.
Exactly.
You know, the tendency to just rely on the stronger side.
Oh, yeah.
And avoid using the weaker one.
Exactly. And the amazing thing is that CIMT doesn't just lead to improvements in movement. Brain scans actually show that new areas of the brain are being activated and recruited to take over the functions that were lost due to the stroke.
So the brain is literally rewiring itself to compensate for the damage.
It really is.
That's incredible.
It's a testament to the brain's remarkable ability to adapt and heal.
Yeah.
And this adaptability extends beyond physical rehabilitation. We also see it in the realm of sensory processing, as demonstrated by Alvaro Pasqualeone's blindfold experiment.
Oh, yeah. Those experiments sound fascinating. Tell me about those.
So he wanted to understand how the brain adapts to the sudden loss of sight.
Okay.
So he blindfolded sighted individuals for several days,
Wow.
forcing them to rely solely on their other senses to navigate the world.
So they were essentially living in darkness, experiencing the world through touch and sound.
Yes, and the results were astonishing.
What happened?
After just a few days, the visual cortex of these blindfolded individuals started showing activity during tactile and auditory tasks.
So the part of the brain that normally processes sight was being activated by touch and sound.
Exactly.
Wow.
It demonstrated the incredible flexibility of the brain.
Yeah.
When deprived of its usual input, the visual cortex was able to rewire itself to process information from other senses.
That opens up so many questions about how interconnected our senses really are.
Yeah.
And how adaptable our brains are. It makes me wonder if our thoughts and emotions, which are also processed in the brain,
Right.
can reshape our neural circuitry as well.
Right.
Can we actually rewire our brains for happiness or resilience or compassion?
That's a fascinating question, and it's one that Richard Davidson,
Okay.
a leading researcher in effective neuroscience, has been exploring for years.
Okay.
He's particularly interested in the effects of meditation on the brain.
Yeah. Meditation seems to be having a moment right now.
Right.
And it's clearly more than just a relaxation technique.
You're right. Davidson's research, especially his work with Buddhist monks who have spent years practicing meditation, has revealed some remarkable findings.
Oh, wow.
He found that meditation can actually change the structure and function of the brain,
Really?
particularly in areas related to emotional regulation, attention, and empathy.
So it's not just a subjective feeling of calm or focus.
Right,
There are actual physical changes happening in the brain.
exactly. His studies showed significant differences in brain activity
Wow.
between experienced meditators and novices.
Okay.
The experienced meditators showed increased activity in areas associated with positive emotions, and a decreased activity in areas associated with stress and negative emotions.
That's incredible. It suggests that we might be able to train our minds
Right.
through practices like meditation
Yeah.
to cultivate positive emotions and enhance our well-being.
It's a powerful idea.
Yeah.
We may not be stuck with a fixed emotional set point.
Right.
Our brains are constantly changing, and with intentional practices, we can influence that change, shaping our emotional landscape in positive ways.
That's so empowering. It suggests that we have more agency over our happiness and emotional well-being than we might think.
Right.
We're not just victims of our genes or our circumstances.
That's the key takeaway.
Yeah.
This concept of mental training, of actively shaping our brains through practices like meditation, is fundamentally intertwined with the idea of neuroplasticity.
Right.
We're not just passive recipients of our experiences.
Right.
We can actively participate in shaping our own brains and, as a result, our own lives.
This deep dive is already transforming how I think about my own brain and its potential. But I'm curious to explore how neuroplasticity plays out in our social interactions and our capacity for compassion.
Okay.
Can our brains change in ways that make us more connected to others?
That's a great question, and one that researchers are actively exploring.
Yeah.
There's a growing field called social neuroscience
Okay.
that's looking at how our brains are wired for social connection
Okay.
and how those connections can change over time.
So how does this social rewiring actually happen? Is there research that shows how our brains change
Yeah.
in response to social connections?
There is one researcher who has done some fascinating work in this area is Philip Shaver.
Okay.
He studies attachment theory,
Uh-huh.
which looks at how our early relationships, especially with our caregivers, can shape our emotional patterns and social behaviors throughout life.
So like how the way we were cared for as children can affect our ability to form healthy relationships as adults.
That's exactly. Shaver has found that people who had secure and loving attachments in childhood tend to be more emotionally stable, trusting and compassionate in adulthood.
Okay.
They're better at regulating their emotions, empathizing with others, and forming strong social bonds.
It makes sense. If you've experienced consistent love and support early on, you're more likely to approach the world with a sense of openness and trust.
Precisely. But for people who experience insecure attachments, perhaps due to neglect or inconsistent caregiving, they often face more challenges with emotional regulations, trust, and intimacy.
So their brains might actually be wired differently because of those early experiences.
That's the idea.
Yeah.
Their brains might be more sensitive to threat and more prone to anxiety or avoidance in relationships.
Okay.
It's not that they're incapable of love or compassion,
Right.
but their brains may have adapted to prioritize self-protection over social connection.
That's really interesting. But if the brain is plastic, does that mean there's hope for change? Can people with insecure attachment styles rewire their brains for healthier relationships?
That's a question Shaver and his colleagues are exploring.
Okay.
What they've found is that even brief interventions that evoke feelings of security and support can actually increase compassion and pro-social behavior,
Really?
even in people who tend toward anxiety or avoidance.
So even just reminding people of positive relationships
Uh-huh.
or experiences can have a measurable impact on their behavior.
It really is.
That's amazing.
It suggests that the brain's circuitry for social connection is more malleable than we might think.
Yeah.
And this has profound implications for understanding how we can cultivate compassion and understanding in a world that can often feel divided.
It makes me think about those conversations that we were talking about earlier between the Dalai Lama and neuroscientists.
Yeah.
And how they were both fascinated by the idea that mental training such as meditation could actually enhance compassion and promote social harmony.
Yes, and Shaver's research provides some scientific backing for that idea.
Right.
It suggests that cultivating a sense of security and connection within ourselves might enhance our capacity for empathy and compassion toward others.
It's inspiring to think that we're not just at the mercy of our genes or early experiences.
Right.
We have the power to change our brains, and in doing so, create a more compassionate and connected world.
This whole deep dive into neuroplasticity has really highlighted that the brain is an incredible organ capable of remarkable change and adaptation throughout our lives.
Yeah.
By understanding these principles and engaging in intentional practices like mindfulness, we can harness this power to heal, grow, and create the lives we want.
This has been an incredible journey into the world of neuroplasticity. It's left me feeling a sense of wonder and possibility and hope. If our brains are this adaptable, imagine the potential we each have to learn, grow, and create positive change in our own lives and the world around us.
Absolutely.
Thank you for taking this deep dive with us.